Hello everyone, welcome to our next video on Python list. We are reviewing syllabus as per CBSE for both class 11 and 12, and Python list is as per your CBSE class 11. Our primary purpose of reviewing this is list is one of the most common building block for writing as well as understanding Python code, particularly when you want to write efficient, effective Python code. So from that perspective, we are reviewing list in brief, and in next video, we will look at some of the list related hands-on, the way we did for the string in our previous video. So let us define list, right? So from mutable and immutable sequences, what do we mean? Mutable is the one where post declaring and assigning you may modify the elements, right? So a list is mutable sequence of elements in Python enclosed in a square brackets. So slowly when you are actually going through so many different symbols, you must keep in mind that the way we declare list is by putting our data set inside a square bracket. So you can look at my example, right? Example for my list, right? Where another important another say flexible things with list is it can handle heterogeneous data set. So in my list, if you see 1, 2, 3 are integer, Python is a string, and true is Boolean. So the same one list can handle a data set of any kind. What are the feature of list? It is mutable, so elements can be changed post declaration and assignment. We can index them, right? Both way, from forward 0 till length of the string and from backward by -1, -2, etc. Nested list, so list can contain other list, right? So for example, in this particular case, your my list might have say numeric one at one place, and maybe the string what in another place, and things like that. And then it is dynamic. What does it mean? The list can grow or shrink as needed, right? So we just tried putting a formal definition around this, and we said that a list is a mutable sequence of elements enclosed in square brackets. Regarding features of list, it is mutable. Indexing is possible both way. Nested lists are supported, and we can grow the list dynamically or shrink it dynamically. Let us look at some of the common key list operation. So we are focusing on item 1, 2, 3, and 4 on the left part of the slide. Let us start with concatenation, which is number 1. So concatenation is by symbol plus, and we can combine two lists into one by using symbol plus. So say if A is 1 and 2, B is 3 and 4, when you do print A plus B, it will be having one list 1, 2, 3, 4. So concatenation of list elements, different list using plus. Repetition, like a string, list also will be repeated as many times. So if your A is 1 and 2 in a square bracket, and if you do A into 3, so your 1, 2 will be repeated thrice, 1, 2, 1, 2, 1, 2. Membership, right? So you can test membership using in or not in. If your A is 1, 2, 3, if you want to check whether 2 in A, right, output is true, 4 not in A, output is true. right? Slicing. So to extract a portion of a list, right? So say if your A is 1, 2, 3, 4, 5, and if you want to access items from 1 to 4, always keep in mind that count start at 0. So your first element is 2, right? And your fourth element is 5, which is exclusive. So you only get 2, 3, and 4. Always keep in mind that your last element is exclusive. That means it is not included, and list counting starts at 0. So after reviewing concatenation, repetition, membership test, and slicing, let us look at how you can iterate over the list. So you have both. You can use a for loop. So for example, if your A is 1, 2, 3, you can say for item in a print item, right? Or if your A is 1, 2, 3, you can initialize I to 0 and you can write a for loop from I, which means 0 till length of A. You can print individual items, or you can actually modify your index to the next one. So in this slide, we looked at key list operation, that is plus, repetition, membership test, and slicing, as well as we looked at couple of loops to traverse the list. There are useful built-in methods for list. So append, right? So when you actually do append x, it adds x to the end of the list. So if A is equal to 1, 2, 3, 4, right, is your list, and if you do A dot append 5, so then 5 will be added towards the end of the list, right? Extending to multiple values. So you can provide, another sublist or list. That's why we are having a square bracket, We are looking at on the left part of the screen under adding element section. You can also insert x at position I, right? So I is again actually counted from 0 till length of list minus 1, and your ith at ith element you can place x. Always keep in mind that insert operations in list are very, very expensive, because it requires internally to move a lot of elements uh, in and around your insert point. So if your data set is such that you need lot of frequent insert, you need to check whether list is an suitable candidate or not. Maybe set or something else could be well suited. Removing elements, remove x will remove the first occurrence of x, right? And pop of I will remove and return element at position I, right? So by default, if you just do pop, it will take the last element. So about pop, you should be very, very aware that it actually helps you remove and return the elements at position ith position, and if you don't specify, it will be at the end. And what remove x does, it removes the first occurrence of x. Searching and counting, you can count occurrence of x in a given list. So if your A list is A is equal to 1, 2, 3, 4, 4, 3, 2, 1, right? And if you want to count occurrence of 4, so you can say A dot count x, right? Index also work. Find the first occurrence of x, so A dot index of 4, right? And what happens if it is not present, then value error will be given. So similar to what you had find in case of string. Sorting, so you can sort the string. This sorting is in place. While when you use sorted, it will return a new sorted list tree. So based on your scenario, whether to use sort or to sorted, you have to keep in mind. Some other useful operations are length, minimum, max, and sum, as well as reversing the list in place. Right? So adding, removing, searching, sorting, other elements. We have reviewed the list manipulation here. Another important thing is, as we discussed earlier also, your list could be nested. So if you see nested is 1, 2 is a sublist, 3, 4 is a sublist. And so if you want to look at nested, 1, it will be 3, 4, right? And then the 0th element of that will be 3. So, keep this syntax in mind, right? Shallow copy. So, it copies the reference, not the data. If your original is 1, 2, 3, and if you copy original, if you assign original to copy, and if you modify the 0th element as 100, right, what happens? Your original also gets modified. There are scenarios when you, so very important, right? Whenever you are doing an assignment operator, this is a shallow copy happening. It means that it's only referring to the both variables are referring to the same memory location, and in that case, when an individual item in that list will be modified by the copy, original will also be changed because both of them are changing to the same location. Deep copy, you can actually import copy function and use copy.deep copy. What it does, it actually creates and make an independent copy of dataset. You can pass list as function argument, right? And there, you can do operation on this, right? So if you are looking at increment list 1, 2, 3, and what that increment list does for individual item in that, it is adding 1, right? So what will be the output here? If you are passing list as an argument, and if you are returning, they will be actually the changes, modification will be reflected. Modifying list inside the function, right? So if you are appending 100, right? Say my list is 1, 2, 3, my list, if you send it to modify, it will be reflected. To increment element of a list, you can do it. To find, for example, average marks. So what you can do, you can look at some of the marks and the length of the marks, right? Very neat. Check if element exists in list. So we are looking at the right part, right? Define, find element, first and num. If num in list, return index of it, else return number not found. Okay. So we have actually looked at increment operator at individual list. We tried using sum and len, find element. So this brings us to the end of this module, that is list. We'll stop here, and in next video we'll actually look at, from your exam as well as relevant course material perspective, we will look at relevant questions around list. Do join us and like and subscribe if you see these materials helpful for you. Thank you, and see you in the next video.